That would be dejecting. It'll probably have about 30 to 40 sections.
Why?
So 30 to 40 problems. You get the whole week to do it.
There's 40 sessions?
I haven't made it yet, but it'll be posted tomorrow, okay? Tomorrow, probably around 9 o'clock. But lesson 96, I saw question marks on A and B, and what else? I don't know if we had a C.
I didn't do the homework.
That would help, yes.
Yeah.
Yes, doing that. A and B. What else, though, guys? Again, A and B.
C and D.
No, there's only A and B here. 4x plus 5 plus 3x minus x equals negative 7x minus 8. Okay, so we talked about this last week. There were no distributive property problems in lesson 96. That wasn't until 103, so we'll only see that during our quizzes review today. Okay, so you guys can get the whiteboards out. If you'd rather work on paper, that's fine too. But what's the order of business that we should apply to problems that have variables on both sides of the equation? And there's some like terms that should be combined. Right? What's the order that we should work in?
On each side.
On each side? So one at a time. Okay, so I'm going to use colors. Remember, you could use shapes, but I'm going to look at everything that has an X in it on the left side. Okay? So since those all have an X, then I'm going to get a little more technical here, an X to the first power and not an X to the second power, we can combine them. How do we know how to combine them? The sign that's in front of it. So 4x is positive, 3x is positive or added, so that would be a 7x. Take away an x. That gives us a 6x. And then plus 5. I'm going to just bring down everything else. We don't have to work everything in one step. We can work one step at a time. I would advise you that if you have gotten lots of these wrong, work slowly. Don't try to skip lines. Now that we have the entire left side combined, right, you cannot add these two and simplify it. So we can say, well, I can add them, I just can't make them one term. So 6x and 5 are not like terms. They'll have to say separate. But, Finley, what do you notice? The negative 7x is over here, so I need to get all the x's in one place. If I'm eventually going to get to this stage, x equals, I've got to get all the x's together somewhere. So how can I move that negative 7x? If I add it over here, it will cancel. That's what I want. But in order for that treatment to be fair or correct, I've got to add it on both sides. So I have 13x plus 5 equals negative 8, okay? Now, the same type of deal. I've got to combine like terms on opposite sides again, but these are called, since they don't have an x or variable, they're called constants. But I do the same thing. To move it to the opposite side, I'm going to use the opposite operation. So I want to move the 5 here. I don't want to move the 13x because that would just be counterproductive. So I've got to do it on both sides. That maintains, all right, so I have 13x equals negative 13. We'll divide by 13 because division cancels multiplication, and we'll get x equals negative 1. And that's a lot of what's going to be on the quizzes practice problems today. Okay? Yeah. Okay, letter B, I have a feeling is very similar. 12x minus 7 plus 8x minus 3x equals negative 5x plus 15. Okay? So if we take Autumn's advice and we work one side at a time, then you notice all of these terms on the left have x with them. So I want to combine those. And again, we just look at the coefficients to tell us what the value will be. 12 and positive 8 makes a 20. 20 and a negative 3 makes a 17. I have 17 x's minus 7 equals negative 5x plus 15. Okay. Same idea here. I want to get all my x's in one place. Whether you choose left or right does not matter. We can choose to move that over to the right or this one over to the left. It's totally up to you. But you may remember me saying I like to have everything positive where possible. That's just the way I brew things. With positivity. Ouch, that hurts. Okay. Huh? No, I don't like doing it that way. Alright. Sometimes you got to, though. So, we'll get 22x here. And then I can think, well, the constants have to get together somewhere too. But since I moved all the x's to the left, I want to move the constants to the right. How would I do that? I've got to do what? Add 7 on both sides. So it had to be plus 7. Had to be plus 7. So I'll get that cancellation. My equal sign is still there. Do not lose your equal sign. A lot of students try to go too quickly and they lose their equal sign. Yeah, don't lose it. And this one becomes very simple. Once we get here, we'll divide by 22 on both sides. And we'll get that x has a value of 1. Okay? Any other questions from lesson 96? No? That's it? Do you guys feel like you're ready for practice? Okay. So, let me get it pulled up. So these are going to be considered multi-step equations. Multi-step equations. So, oh no. I can't pause. Well, I think I can pause it. There should be a pause button. Okay, there's not a pause button.
What is this?
Camera's still going.
Alright, yeah, the timer is still going. You want to work on paper or whiteboards?
Whiteboard. Can I pass out the
I don't see where they are. They might be on a different
I want to pass out the marker. I never got to.
cart.
How long did y'all stand before they had to go? Oh, yeah, man. No whiteboards, no
Oh, they're right under that.
Oh, they're just organized much better now that
Now let me and Chris.
they've gotten rid of my other stuff. Yeah, you want to pass those out for me?
Not really.
Well, there you go.
There's only one more. I think you got Luke, I swear. 2, 3, 4. I guess so.
But he did give me
No, markers. What? Well, Billy is plenty for you.
Alright, so this one shouldn't take you very long. 4x plus 6 plus 3 equals 17.
Oh, I didn't know you started it.
It is back. So again, if we want to remember our steps,
Do I call it out or do I just hold it up?
hold it up.
It's gonna be probably not. Oh, I have to do that first. Okay. No, they're all mine. Knowledge.
I feel like they only know that the wrong answers. Like they know what common wrong answers are, and they put them on there. It's confusing.
Yes,
So
that is the way most tests are designed these days.
And you're like,
When it's multiple choice,
right.
they want to know that you definitely know what you're doing, not that you just get lucky with educated or slightly educated guesses. All right, so I see at least 3 tables with the correct answer. What we're going to do first is combine the like terms 6 and 3. We'll get 4x plus 9 equals 17. Then we'll subtract 9 from both sides, so we'll have 4x is equal to 8. So x must be 2. If 4 times a number...
It was Norwich.
All right, so you look at what you did, Avery.
Yeah.
You can't detach a 4 from a 4x. Not by subtraction anyways. You'd have to divide. And those aren't like terms. So make sure you're combining your like terms. Yay! 2. Positive 2.
Immunity.
Okay.
Solve for the variable k in the following equation.
Please turn
7k minus
It's
1
not me.
minus 6k
It's not me.
is equal to negative 6.
Ouch.
This guy's voice sounds.
You could determine if somebody is a math teacher by the sound of their voice?
Yeah.
No.
Yes.
Yes. Yeah, you really.
I really can.
For the way they talk.
2 tables are
Your
done.
math voice is smart.
Just the words they use. Yeah, my
They know what they're
talking
about.
about.
3 tables it is. So we'll combine the like terms 7k and minus 6k and get 1k. Or
1 kilogram.
k minus 1 equals negative 6. Now notice the k moved to the front. The k moved to the front. Oh, I didn't show you that part. Hang on. The k moved to the front. They're around here somewhere. There's a magic eraser there too if you want to use that.
That was
So I could have said, negative 1 plus k equals negative 6. That says exactly the same thing with a different order. But positivity, me, I like to have the variable in front. It's just easier for me, or maybe it's more familiar. Okay, but both of those would be correct. Why is that okay? Because the k is positive in both of them. The 1 is negative. Because this is a variable and a constant, we can write it either way, and it will give you the exact same value. Okay, but I think it's easier to do it this way. So if we have k minus 1 equals negative 6, I can clearly see that if I add 1 to both sides, I'll get k alone, and I'll get a value.
Is even an answer choice?
I don't believe so. All right, next. What do we get, Nick? That wonderful sound.
You got it wrong.
All right, let's have some fun.
Because he got some.
So this is where we're advancing to lesson 103. Distributive property. I hear some good vocabulary here. Is that your favorite soccer team? Tottenham.
Mine's white. Manchester United, Bayern Munich, they're red.
Oh, are you telling me what the answer is, or you just
Liverpool is red. No, I don't know what the answer. I'm just saying the teams that could be red. Oh, Ireland.
Chelsea?
That's blue.
All right. So how do we, quote unquote, do the distributive property? What do we actually have to do?
distribute.
All right, Quentin. What operation do you imply when you say distribute?
Multiplication. Okay.
Multiplication. Okay. So I'm gonna remember I did these little marks here. I'm gonna do it again over here, and I'm gonna color code it. You need more time on it,
Yeah.
or I'm just gonna let that part show for the time being.
Yeah, I did that. I don't know what
Cool. Hold it up, Brooklyn.
I don't think it's right. I don't think it's right.
-6. All right. Is that an answer choice? Let's see. Not an answer choice, so probably not right. 2. All right, that is an answer choice. So we got a table with 2. Some other folks still working. Another one that said, how'd you get that?
Daniel, I gave you the marker.
You only showed those steps. You got to show more. Yes, ma'am.
I think we really need it.
All right. Well, remember, I don't know that this will be on your final exam, but I wanted to give you the preview before Algebra 1. So, if Quentin's right, and he is, when he said to distribute, we have to multiply, but that means the -5 is going to visit each party inside the parentheses. All right, that's the United States strategy in World War II in the Pacific. It was called island hopping. 8th graders, did you read about it? Island hopping. Hopping from island to island. Luke, why don't you sit down? Please sit down and work with us, sir. So, -5 times 4x. What was that? What is that? That's a -20x. -5 times -2. Luke, please have a seat and work, buddy. +10. All right, let me color code those to make sure we know exactly where they came from. Now, if you didn't do the right side, please do the right side now. Now that you know that distribute just means to multiply. Okay? Visit each party inside. Go to every grandma's house at Christmas.
Wait.
That's all I mean, is that the number outside is going to visit every term, and terms are separated by plus or minus signs. So, -2 times 3 is what I mean, Luke. What is that? -6. It's pink. -2 times +6x. What would that be, Nathaniel? -2 times +6x.
-2 times +6.
-12x. Okay, we've got to make sure we remember the x just kind of comes along for the ride. Now it looks like the problems we did from lesson 96, because now we got rid of the parentheses. Okay, Luke, put the tower down. All right, so what do we do now? Autumn, can you help us now?
Now you gotta get all the x's to one side.
All right, what side do you want to do?
What?
Move them to the left? So how would I? So I want to leave this one here. I want to move this one over. Since it's negative, I want to move it to the opposite side. I'm going to use the opposite operation. So cancel out. -20 plus 12.
-8.
-8 x's remain. Okay, and I have my +10 here equals, what's left over here is just the -6. Now I'm going to do the same thing. I want to move the constants over to the other side. So subtract will cause it to cancel out here and reappear over here. -8x equals -16, and we'll divide by -8. Again, we want what coefficient do we want with the x if we have to have one?
None. Or 1.
1. So whatever we divide by must create a 1x here, or just x. And you can see that the two groups that got 2 are correct. Northwick, okay.
Wait, it was Liverpool again?
Huh?
10.5.
Liverpool's a city in England.
So is Manchester, right?
Liverpool.
Oh no.
It's better than Chelsea.
All right, next problem.
Liverpool. Wembley. Liverpool's better than Wembley.
Okay. -6n minus 2n equals 16. Ooh, we show all the grades, don't we?
You can just like go in there.
Don't show mine. This is 8th grade, I think.
Yeah,
Search history.
probably on the school.
Somehow. Yeah, do you like hack into our computers? I feel like you do. I feel like you like to know everything. Are you watching us?
No, I was only able to do that at our last school.
Oh, at your last hit.
Well, all those devices were given to the students from the school, so they were school property, and we had to manage them, not while you were at home.
So you should watch them?
Yeah, I can pull up everybody's screen on my screen and shut it down if you're on a site you weren't supposed to be on. We don't have that now, but
What school are you at? I'm at Algebra. Okay.
so you got -2.
Yay.
So if we combine these like terms, we're going to get -8n equals 16. We'll divide by -8. This is a pretty straightforward one, right? What is straightforward anymore? I like NASCAR. Go left.
Just in order to like the
Oh, yeah.
All right, we got time for a few more.
It's cringy, but like, the answer's gonna be.
know they could like log into our screen. Yeah, but I know.
It didn't talk.
Anytime a school gives technology as something for students to use at school property, they have to make sure students are using it ethically,
I just
correctly.
didn't know how they did that. I thought they like could see what websites you were searching up, but now it's your screen.
Oh yeah, I could send messages. I could send a message straight to a person who was like, "Are you doing your work right now?" Question mark.
Could you see
Well, that would be-
could you see like students to each other? I would just text back and say no.
I could pull up their screen, so if they were like on Google Hangouts, you guys know what that is?
Yeah.
I could see them using that.
They used to do that. They used to do that in my old school.
Yeah, they still do it everywhere because again,
And people got in trouble because they were searching up stuff.
people don't do what they're supposed to do in most cases unless they're forced to do it.
I just never used my school phone.
All right. Oh, you did it. Okay. One table. Hold yours up.
It's not even an answer.
Oh, it's not an answer. You must have done a little tiny arithmetic incorrectly. So we have -6 as one answer.
I got -5, so. I got
-6 from 2 tables. Waiting on a third table. +2, -6, -6. All right. Don't forget your variable, Madison. Don't lose sight of it. So writing this one, 6r plus 7 equals 13 plus 7r. So we'll move all of our r's to I'm going to move it to the right. Because I'll still get the same answer as you if you did everything else correctly. And then I'm going to move the 13 over here. 7r take away 1r is just r. 13 cancel, 7 minus 13. There it is. Okay? Alright, let's fast forward a little bit to something a little more challenging.
What was the answer?
-6. Did you get that one?
What's more challenging than this?
Oh, this makes sense.
This one's gotta be.
Don't begin to make guesses about all the color it has to change because
Use like the top.
I'll be honest.
Community and the double.
Are you doing all two right now?
Yeah.
Use all the like power.
No, I'm not done. I just wrote it. I didn't make this one. No, I didn't make this one. I used to make lessons on there that students could do independently, so it would have like teaching slides, teaching videos embedded on there, and then you have a question and then a video or a lesson and a question.
What are you gonna say? Delta minus. That's in the budget. Delta minus is 2.
I would appreciate it if you stopped. Okay.
You gotta make sure you can replicate the sound, otherwise people will look at you like, ew. Okay. Squeaky floor. So, before lesson 103, the first thing we should do is combine like terms. But the comparison or the analogy I used to make is that a parenthesis is like a penitentiary.
What's that? What's a penitentiary?
Jail.
I can't even do that. How do you do
And
that?
people can't just... What did I do?
You stuck one eyebrow like all the way up.
It's a rock.
All right, so Here's the thing. You can't combine these terms yet. Keyword yet. You can't combine this minus 2x with this plus 3x because it's in a parentheses penitentiary. That's why I do that. I have fun with alliteration, where you use the same first letter of words to...
Why don't you just say parentheses prison?
Hey, penitentiary is a vocabulary word.
But no one knows what it means.
You do now. It just means prison. 10. It is an answer, so Natalie may be on to something. 10. That's 2 for 4. 2 out of 4, I should say. So, long story short, you can't break something out of prison. You've got to distribute to get rid of the parentheses, okay? So, we'll get 10x plus 30 equals, so we're going to distribute over here, positive 20 plus 8x plus 3x. So it's not actually a negative 2x that combines with a 3x. It's an 8x. Okay? So those two terms are alike. We'll leave the left side as is for the next step. And what will we get when we combine those, Avery? Bless you. Good timing there. 11x. All right, now that we have both sides completely simplified, there's a word there I want to make sure you understand. Mathematically, it's more specific than just simpler. To be simplified means that nothing else can be combined on that particular side. Those aren't like terms, so they have to stay separate. Same thing is true of 10x plus 30. So that is simplified, kind of like when you can't reduce a fraction anymore. Okay? So then I realize I need to get all my x's over to the right or to the left. Let's say to the right. Again, I'll see the cancellation here. And then that means I'm going to move all the constants to the left. So I'm going to move the 20 over there by the opposite operation. And so I'll get 10 equals x. What does that mean? The same thing as x equals 10. Okay, the reflexive property, A equals B, therefore B is equal to A. Equal sign goes both ways, guys. Okay? All right. 928. Let's see what else we got on here. No, that was too easy. Yeah. Oh, I didn't mean to do that. I guess we'll keep going. But I'm probably going to get this one wrong. So just, huh? Yeah, all right. Aha! Next problem. So I don't know what number this is, but that's okay. We're not numbering these. And you can. 24 equals 3 times the quantity 3x minus 7. So one of the reasons you can't just break a term out of the parentheses is because of order of operations. Okay? All right, one table with an answer. Another table with an answer. I believe it's the same answer. And they did it 2 different ways. All right, I see the same answer showing up a couple times. Okay. How'd you get 10x? Does this have an x? Then they cannot combine with that. Okay, so those have to stay separate, so you got to do something else.
Go away.
Another 5. Another 5. High five. Because that's the greatest number of answers I got right now.
High five.
Yeah. Speaking of, hey, how was the dance?
Really bad.
My legs hurt so bad. It was fine. I'm so sore that still. Let me try to get
Never want to wear those heels ever again. But,
Way to slug it out. Okay, so I'm going to do this 2 different ways. I saw 2 methods on your whiteboards. I saw two methods on your whiteboards.
Got it last.
The first one is what we've been doing. Let's make sure everybody is clear on all of these steps. You cannot combine, oh, is it a plus or a minus 7? It's a minus, okay. You can't combine these. Why not?
Because they just don't work like that.
Because they're not. I forgot.
They're not like terms, okay? It seems like they'd make a better nickname for that, but you can't combine these, so they have to say separate. The other reason I gave you last week was order of operations prevents us from subtracting before we multiply. So, we're stuck there. But, wait, we know how to get rid of the parentheses. We're going to
You're going to.
distribute, which is multiply. We're going to visit each person, so I've got 24 equals 3 times 3x is
9x.
9x. 3 times negative 7, negative 21. All right, so from there, then I can say, well, I need to move the 21 over here. I will add it. So I've got 45 equals 9x. Last step,
That's what I did do.
divide by 9. So x equals 5. But I said I would do this a different way. I said I'd do it 2 different ways. Now, this was not possible on some other problems, or it was, but it wasn't a good idea. Okay? There are such things as bad ideas. Okay? So, instead of distributing the 3, answer this for me. What is the 3? How is the 3 attached to parentheses? What operation?
Multiplication.
Multiplication. So instead of distributing, what if we just decide, let's cancel out that multiplication anyway? So it doesn't happen. How do we cancel out multiplication?
Divide.
If we divide both sides by 3, we won't have to worry about distributing. So 24 divided by 3 is 8. So I'll have 3x minus 7 equals 8. Then what?
Do math.
Do math. Move the constants over. So I want to leave the 3x. It's already just one place, so I want to move the other stuff. By the opposite operation, I have 15 equals 3x. We'll divide by 3 on both sides, and we'll get x equals, oh yeah, it's 5.
Wait, what's Norway?
What? Oh. Oh, I see.